Hi, and welcome to our 144th test and measurement video. Today's topic is the Tektronix MDO 3000 series internal library of arbitrary function generator waveforms. There are 14 of them in all, including the user-defined arbitrary function. After powering up the oscilloscope and allowing it to boot up, representative waveforms can be accessed by pressing the AFG button located just below the digital controls on the front panel. The last used waveform is displayed. To go to the top of the list, press the waveform button at the left end of the lower horizontal menu and scroll up using multipurpose knob A. We'll skip arbitrary for now and go to sine, the second item in the list of waveforms. To display it, a BNC cable has to be run from the AFG port on the rear panel to the analog channel input port that you wish to use. Press menu off to remove the list of waveforms, leaving sine displayed on the oscilloscope screen. Be sure that the correct analog channel button is on. The sine wave is a graph of the trigonometric sine function displayed in Cartesian coordinates. That is to say, amplitude is plotted in volts against the vertical y-axis, and time is plotted in seconds against the horizontal x-axis. The unique thing about the sine wave is that the rate of change slows down and is at its minimum as it approaches maximum positive and negative amplitudes. And the rate of change is maximum as it approaches minimum amplitude where the trace crosses the x-axis. This same behavior occurs in many natural and human-made phenomena, such as the pendulum, which comes to a stop as it reaches its maximum height above the center of the Earth. That is why the sine wave is important in diverse fields, such as music, ocean waves, and statistics. The square wave is flat. That is, zero rate of change at high and low amplitudes, with a very fast instantaneous rise and fall time between these high and low states. It is used in clocks for timing electrical events in computers and other devices. The pulse, of which the square wave is a limiting case, is similar, the differences being that the high and low periods are unequal. The ramp wave is also similar to the square wave, except that, as the name suggests, the rise and fall times are gradual and linear rather than instantaneous. There are numerous applications in electronics where comparators set stepped voltages. DC and noise are familiar to all of us. Sine x over x is the sine function of a quantity divided by that quantity. Gaussian is a graphic representation of the normal distribution of random events, the so-called bell curve. Lorentz is a linear transformation from a coordinate frame in space-time to another frame that moves at a constant velocity to it. It is applicable to Einstein's two relativity theories. Exponential rise and exponential decay are self-evident. The Haversine formula determines the great circle distance between 2 points on a sphere, given their longitude and latitude. Cardiac is a non-dynamic representation of a blood pressure wave moving through the human heart. Thanks for watching. New videos are added periodically, so check back frequently.